Hi, hello everyone. Welcome to SK Academy of Mathematics. Today, let us learn how to solve the problem on changing the order of integration. First, let us represent the given integral, define the limit points, change the limit points, and integrate with respect to the given variable dy and the derivative dx or dx and dy. First, let us represent the given integral. That is solution I, which is equal to integral 0 to infinity x to infinity e power of minus y by y dy dx. First, whenever they give the integral, first we need to represent with respect to I and define the limit points. Define the limit points means if the first limit point is defined with respect to x to infinity, if any limit points is defined with respect to x corresponding to the opposite variable, I need to define, that is I need to define with respect to y and I need to integrate with respect to y itself. Remaining variable is x. Now, but changing the order of integration defines I, which is equal to, first this integral will be changed with respect to y and this integral will be defined with respect to x. This is the our main aim, that is e power of minus y, and equation remains same, y dx dy, dy changes to dx, dx changes to dy. But the point, now considering these limit points, we are going to represent the limit points. How? First, consider the given x equal to 0, this is lower limit and this is upper limit, y x equal to infinity, x equal to infinity. Now we have y equal to x and y represent infinity. Okay, done. Now if I substitute x equal to 0, if x equal to 0, then y equal to 0. What will be the limit point? Y equal to 0. Or if x equal to infinity, then y is also equal to infinity. Upper limit also infinity. But to represent the variable x, now I need to represent the graph. How? By considering these limit points, considering lower limit points and upper limit point. First, let us consider x and y axis. I have explained always, if x equal to y, they have given the function or the equation, it should be a straight line in the x and y parabola, like x and y plane. If it is defined with respect to x square function, the parabola is defined with respect to u shape. If it is defined with respect to y square, the parabola is defined with respect to c shape. Now, since we don't have x square and y square, just we have what? X equal to y. So what I am going to consider? I am going to consider a straight line. Okay, done. That is x equal to y. This is our x axis and this is our y axis. Now, since x equal to 0, what they have given? First, see, we have represented x equal to y, x equal to 0. That means this base will be equal to 0. Whole base will be equal to 0. But where is still up to infinity. Y goes on up to where? Up to infinity. What the point? Similarly, x is also up to infinity. But what we are going to consider, considering this only, we are going to represent the graph. That is, since x is equal to 0 to infinity with respect to y equal to x, this is the intersection part. This will be our intersection part. That's it. Why? Since corresponding to the limit point, when the interval is 0, see, it is going from 0 to infinity. But the limit points will be 0, starts from 0. Excuse. Now, first let us look into the limit point. See, we have y equal to x, or else x equal to y, or let us represent y equal to x. Y equal to x2 goes up to infinity. See, this goes up to infinity, goes on up to y equal to infinity. From where? Here to here. Got the point? Goes up to infinity. But after changing the order of integration, see, this will be our lower limit and this is our upper limit. If you check to the given limit point, see, y equal to x is our lower limit and y equal to x is our upper limit. That is, since it is been vertical, that is y equal to x is our lower limit and y equal to infinity is our upper limit. I have told so many times, if you get vertical, change it to horizontal, so that this will be our lower limit, this will be our lower limit and this will be our upper limit. First let us see which is our lower limit. This to till here. What is our lower limit? This is our lower limit and this is our upper limit. What is our lower limit defined? See, lower limit is defined with respect to what initial line? Initial line x equal to 0. That is x equal to 0 and goes up to the upper limit point. Upper limit, what is, for which perpendicular is drawing, that is y equal to x. Since I need to represent with respect to x, so what I am going to consider, x equal to y. Say this is our lower limit and this is our upper limit. Why? Since the initial line x is equal to 0, based on this x equal to 0, we are going to consider the represent. So why we are not going to take infinity? Because this infinity goes up to the intersection part, so we don't have. So from where the initial line goes to infinity, from here, see, it starts from 0. 0 to in which direction? It goes with respect to up to y x direction. Which direction? See, it is going up to this direction. So it is going from where? 0 to infinity. With respect to which direction? X direction. Based on this itself, we are going to represent the initial line x equal to 0. This is how we are going to represent. That is, lower limit is equal to 0 and upper limit is equal to y. Why? Because y is based on x. If I give the value of x up to infinity, I can give anything. If I give x equal to infinity, y is also equal to infinity. With respect to which direction? With respect to x direction. So we have represented the initial as 0. Got the point? Now let us integrate this part. First, I need to integrate with respect to x. So I, which is equal to y varies from 0 to infinity, e power of minus y by y remains constant. Integration of 1 with respect to x is x. Limit varies, okay, sorry, this is not infinity, 0 to what? 0 to y. 0 to y. Because since I am going to represent with respect to x, that is 0 to y. X equal to 0 to y dy. I, which is equal to y varies from 0 to infinity, e power of y by y into y minus 0 dy. Y minus 0 is y. I, which is equal to y equal to 0 to infinity, e power of minus y by y into y dy. Y get cancelled. I equal to y varies from 0 to infinity, e power of minus y dy. Integration of e power of minus y. Since we have minus 5, we have integration of e power of minus y, that is e power of minus y divided by minus 1. Okay, that is integration of e power of ax equal to e power of ax divided by a. Since a is minus 1, so we are going to consider minus 1. Y varies from 0 to infinity. I, which is equal to e power of minus minus infinity by minus 1 minus of e power of minus 0 divided by minus 1. That is, e power of infinity is 0. 0 by anything? 0. Sorry, e power of infinity is 0. Okay. Now, e power of 0, 1. Anything power of 0 is 1 divided by minus 1. Minus into minus, you get plus 1. This is our required solution based on the given integral with respect to, after changing the limit points with respect to y and x and reducing the given integral. This is how we are going to represent the step by step solution of the given integral for the given condition by representing the graph. I hope you have understood this problem. For more videos, please do like, share and subscribe. See you in the next video. Thank you.